Hi, welcome to Math Minute. My name is Adam, and today we're going to be talking about limit laws. Limit laws are really going to help us try to turn that secant line into a tangent line that we talked about last time. So, when working with limit laws, these are the things that we really want to know. These are our goals all the time. We always want to turn our limit into this right here. The limit as x approaches a of just x. What we can do with that is the direct substitution property, where we can just plug this a value in and it will just equal that a. Now this is just another thing. This says if you take the limit of a constant, then it equals that constant. So if I just did something like 2, whatever this number is, it's not going to affect that because 2 is just 2. So this is going to equal 2. Now for this, if this a was like a 4, the limit as x approaches 4, x is just going to equal 4. So with limits, I'm sure you've looked at them a little bit, so let's just remember those when we're going through these laws. So now, what I recommend you do is get out a piece of paper and take notes along with these, so you have like a sheet of paper with you to refer back to for these. This first one has to do with addition and subtraction. So if we have a function plus or minus another function, and I'll just put minus for this, we can split this up into two limits. X squared minus 2x. Now if this was a plus sign, this would become a plus sign. So really we can worry about this a little bit different. We can split this into two, because our goal is always to turn into this, and that's what we're doing. We're getting one step closer. So the next one has to do with a constant. So let's take this one, or specifically this limit, and let's talk about it. So if we have a constant number multiplied by a function, we can take this constant out and worry about it later. So we'll just worry about solving this limit, and then we'll just multiply it by 3 at the end. The next one has to do with multiplication, very similar to the addition, subtraction. So if we have a function times another function, we can split it into two limits. So the limit as x approaches a of x times sine of x. Just splitting it again. We're just once again trying to get this to look like this again. And as you see, this one worked. We would just have to do a little bit more for that. So rule number four is division. And as you can imagine, it's going to be the same idea. So if we have the limit as x squared plus 1 over x minus 1, as you can guess, splits into the limit of x squared plus 1 over the limit of x minus 1. Now the one thing to notice is this value that x approaches is the same for all of them. For this I just left it as a because a can be anything, 2, 3, whatever you'd like. So all we're doing is we're splitting this and we're remaining x to be approaching the same thing. So the last one has to do with exponents. And if you can imagine, it actually is an extension of rule number 3. I'll let you try to figure that out on your own, maybe some food for thought, but it's kind of interesting if you can figure it out. So if we have a function raised to a power, we can split this out, take this exponent out, and square, or in this case square, whatever the answer is. So we had the limit of x squared, that we could say the limit as x approaches a of x, and then square whatever we get as the answer. Because this is just this. That's what we want. So now I'm going to do a problem real quick, and I'm just going to try to use all the rules. So let's take the limit as x approaches 2 of 3x squared plus 2x. So what we do from the very first rule is split this into 2. So this would be the limit as x approaches 2 of 3x squared plus the limit as x approaches 2 of 2x. So we've been able to split this into 2 using the first rule. Now let's apply the second rule, which says if we have a constant times a function, we can take that constant out. So in this case, we had a 3, so we can put this 3 out in front. And over here, we had a 2, so we can put this 2 out in front. So now as you notice, this is already perfect. We've already gotten to the goal of the limit laws. We have one more step over here, and that is using rule number 5. We can take this exponent out, which in this case is 2. So this becomes squared. So now this and this are exactly what we need. Limit as x approaches a value of just x. And what the direct substitution property says is that we can just plug this value in. plug it in. So we'll say 3 times 2 squared plus 2 times 2, which is just a new value we're going to find. So 3 times 4, 12, plus 4 equals 16. So your final answer would be the limit as x approaches 2 of 3x squared plus 2x equals 16. So this is going to help you when you actually have to start solving derivatives using the definition of a derivative, which we'll talk about a little bit later. But right now, this is going to be the same basic process you're going to use when you start to get more in depth in derivatives. So I would recommend you get good at noticing rules from an equation, when to use them, and how to carry out the problem. So these steps will really help you with that, and hope it's been helpful, and we'll see you next time.